Hello everyone, this is ML Naruto. Welcome to my channel. So today I'm going to teach the topic of divisibilities. So this is the today's topic here. So now so I'll tell you how to check the divisibility of 2 and 3, 9, 4 and 5, 10, 11 and 8. So I'll tell you each of these divisibilities. So first of all, let's have a look at this particular number, that is 2. So divisibility, what is the condition for which a number, if any number has to be divisible by 2 here? So 2 here. Okay, so how can you decide that if any number is actually divisible by 2? How to decide that? For example, I have some kind of number like see, I have some kind of number like 2, 4, 9, 8. So I just want to know whether if I can find out that this number is actually divisible by 2 or not. I want to find this. So how can you find this? We can't even just simply do division like this, like 2, 4, 9, 8. If I want to check this, so 2 ones 2 and 4, 2 twos 4, 0, 9, 2 fours are 8 and 1, 8, 2 nines are 18. So it's actually getting divisible by 2. Okay, so this is actually getting divisible. But how to check? But this kind of checking is a whole lot. Whole lot process. So it involves time consumption. So we don't want to approach this particular process here. So instead of following this particular process, we have another process, that is the divisibility condition here. If you can check the divisibility condition by 2, then you can confidently say that this particular number is actually getting divisible by 2. Okay, so how to do that? For example, here in the this is known as the units place or the ones place. Okay, this is the units place or the ones place. So if if the unit place of any number has 0, 2, 4 or 6, 8, if any number, if its divisible, if its units place has these numbers, then you can surely say that this entire number is actually getting divisible by 2. You can say that only if its units place has these numbers. For example, I can say that for example, I have some number like 7292. Is this number is actually divisible by 2? You can just need to look at this particular units place. See the units place here. The units place is 2, so it's definitely divisible by 2 here. Okay, so you can say that, you can check like this. This is the divisibility rule of number 2 here. Okay, so I'll tell you what is the divisibility. Now we can talk about this particular number, that is 3. Okay, so how to check if any number is actually divisible by 3 or not? So for example, I have some kind of number here like 7, 2, 9, 8 and 6 here. So I want to check whether this number is actually divisible by 3 or not. So how to do that? What we can do is we need to add all these numbers. For example, 7 plus 2 plus 9 plus 8 plus 6. How much? 7 plus 2 is 9. 9 plus 9 is 18. 18 plus 8 plus 6 is 14. So 14 here. So what is this? 8 plus 4 is 12. 1 plus 1, 2 plus 1, 3, 32. So we need to know that, see here, this particular number, that is 32, right? Okay. So you need to add this all the so you need to add all these numbers 7 plus 2 plus 9 plus 8 plus 6. So you will get some kind of number here, that is some number, that is maybe in this case 32 is some kind of number, right? So you need to know whether this particular number is actually divisible by 32 or not. You need to know this is not divisible by 3, right? I mean 32 is not divisible by 3. You can't perfectly divide, right? So you can say that this entire number is not divisible by 3 here. So you can say that. For example, let's consider another example like 93 here. So I want to know whether this particular number here is actually getting divisible by 3 or not. I want to know. So what I can do is I'll just simply sum it. 9 plus 3 is equal to 12. So 12 is divisible by 3, right? Yes, 12 is divisible by 3. 5 by 3 4 12, right? So you can definitely say that this number is also divisible by 3. You can say that, right? So the rule is the sum should be divisible by 3. Then we can say that the number is also divisible by 3, right? So you need to calculate the sum here, and if this particular sum is actually divisible by 3, then you can definitely say confidently that this particular whole number is actually getting divisible by 3. In this case, it is not divisible. Why? Because 32 is not, is not uh, divisible by 3 here, right? But when you look at here, 12 is actually divisible by 3. So you can definitely say that 93 is actually divisible by 3 here. So this is the divisibility rule for the number that is 3 here, right? Okay, so let's move on to another rule. So now next is the divisibility rule of 9 here. Okay, so this is the divisibility of rule. So this is very much similar to the previous divisibility rule of 3. Why? Because see, I have some kind of number. For example, okay, let's take this particular number, that is 93. Okay, let's take the previous example. So you need to sum it up. 9 plus 3, what's the value? 12. So you need to check whether this particular number is actually divisible by 9 or not. No, you can't divide. Why? Because see here, 9 ones 9 and 3 here, 0.0, and 436, 93 is 27. So it's not getting divisible by 3, uh, divisible by 9. So you can definitely say that this this particular number is not divisible by 3. Hence you can say 93 is also not, this particular number is not actually divisible by 9. Okay. So hence you can say 93 is also not divisible by 9. You can say that. But when you look at another kind of example, for example, I have this number like so I have this number. So I want to check whether this particular number is actually divisible by 9 or not. So what can I do? I need to sum it up. So 9 plus 9 is 18, 18 plus 9 here. So nothing but the 27, right? So we need to check whether this number is actually divisible by 9 or not. So let's have a check here. And there is 27. So it's actually getting divisible by 9. So you can say this number is divisible by 9. Hence, this entire number is also divisible by 9. So this would be the divisibility rule. That is, the sum should be divisible by 9. Then only number will also be divisible by 9. So this is the divisibility rule of 9. Okay, just move on to the next rule here. So now you can look for the divisibility rule that is 4 here. So how to find any number, whether it is divisible by 2 or whether it is divisible by 4 or not. So how to do that? For example, I have some kind of number like 2, 8, 7, 2. Okay, I have this number. I want to check whether this number is actually divisible by 4 or not. So how to do that? So you just need to check these two digits, right? That the last two digits, that is the ones and the tens here. So you need to look for the last two digits, okay? And if those two digits are actually divisible by 4, then you can confidently say that this whole number is actually divisible by 4. How to do that? Just look at here. So what are the last two digits here? That is 72. Can you say that this number is actually divisible by 4? See, let's check here. 4 ones are 4. So 3 here, 2. 4 eights are 32, right? So you can say that 72 is actually divisible by 4 here. So you can definitely say that this whole number is actually divisible by 4 also, right? I'll tell you another example. For example, 132 here. So just have a look at the last two digits of the number. What is that? 32. That is 32 is divisible by 4. Let's check. 4 8s are 32, right? So you can definitely say that this 32 is divisible by 4. So hence this whole 132 number is also divisible by 4. So that is the divisibility. That is last two digits should be divisible by 4. Then only you can say that that the entire number is actually getting divisible by 4. This is the divisibility rule by 4, right? So now just move on to the another divisibility rule. Okay, so this time we gonna look for the divisibility rule of 8 here. Okay, so how to decide whether any number is divisible by 8 or not? How to decide that? Okay, let's take an example like okay, for example 2, 9, 8, 7, 6. Okay, see here, this is the some 5-digit number. 1 2 3 4 5. Yeah, this is a 5-digit number. So you want to know whether this particular number is actually getting divisible by 8 or not. You just want to check it. So how to do that? The condition is nothing but the last three digits. You need to look for your last three digits here. That is 876. Just look at here, 876. Okay, so you need to check whether this number is actually divisible by 8 or not. So let's do that. 8 ones are 8, 0, 7, and 6 here. So 8 nines are 72 here. So 4. So sorry, I think So if you look at here, 8 ones are 8, okay, 0, then 7. So it's not, it's less than, so you can put 0 here and you can just take it 6 here. So 9 8 is 72 here. Now 4, if you keep 1 point here, so you'll get 0, and 8 5 are 40 here. Yes. So it's actually getting divisible by 8 here. Okay. So this particular number is actually getting divisible by 8. So hence you can say that the whole number is also, this entire number is also divisible by 8. I'll give you another example. Just look at here. I'll give you another example. The example is for example 1678935 2. So this is the 1 2 3 4 5 6 7 8 8-digit huge number. Okay, so if you want to know whether this particular number is actually getting divisible by 8 or not, so you just need to look at this particular last 3 digits, that is 352. Just look at here, 352. So you need to understand, you need to know whether this particular 352 is getting divisible by 8 or not. So let's have a look at it. So 8 4s are 32 here. So 3 2 8 4s are 32 here, right? So this particular 352 is actually getting divisible by 8. Hence you can confidently say that the entire number is also getting divisible by 8 here. So the condition is the last 3 digits should be divisible by 8. So this is the divisibility rule for the number 8, right? So just let's move on to the next divisibility rule here. So the divisibility rule now we're going to look for is the number itself, the 10. Okay. So how to know how to know that whether any number is divisible by 10 or not. So let's have a look at here, 2 9 7 8. So I want to know whether this particular number is actually getting uh, divisible by 10 or not. So how to check that? So how to do that? You just need to look at here. See the units place. If this particular units place is having the number 0, then you can confidently say that this entire number is actually getting divisible by 10. Hence, since here the units place is not occupying with 0, it is some other thing like 8. So you can't say that the entire number is actually getting divisible by 10. So this number won't be divisible by 10. So if I can say that 150, I have some kind of number like this. So I would just want to know whether this number is actually getting divisible by 10 or not. So you just need to look at the units place here. If this units place is having 0, you can confidently say that the entire number is actually divisible by 10. So the condition is nothing but the units place should have the number 0. Then only you can say that the entire number is actually getting divisible by 10 here. So this is the divisibility rule for the 10 here. So now we gonna look for the number of the divisibility rule for the number, that is the 5 here. So this is pretty much simple. So if I have some kind of number like this 2 9 5 here, okay, I want to know whether this particular number is actually getting divisible by 5 or not. So what can I do is I just need to simply have a look at this particular units place, that is this particular last digit here. What is the last digit here? 5. The condition is nothing but the condition is if units place have either 5 or 0, then you can say that the entire number is actually getting divisible by 5. See, since this number has 5 in its units place, you can confidently say that the entire number is actually getting divisible by 5 here. For example, I have another number like I have 15090. So I want to know whether this particular number is actually getting divisible by 5 or not. So you just need to look at this units place, that is 0. So you can confidently say that this number is also getting this particular number is also getting divisible by 5. Okay, this is the divisibility rule of 5 here. Okay, so let's move on to the next one. Okay, so now we're gonna look for the divisibility rule of the number that is the 11 here. Okay, so how to check whether any number is divisible by 11 or not? So how to do that? For example, I have some kind of number like this 29435 so I have this number. I just want to know whether this particular number is actually divisible by 11 or not. So how to do that? I need to spot out all the odd places and I need to look for all the even places. What are all the odd places here? Odd places are nothing but these are the odd places, that is 7, right, 4, 3, 9. These are the odd places here. So odd places equal to 7, 1, 4, 3, 9. Okay, so what are the even places here? Even places are these 1, 5, and 4, 2. So how do you decide which one is the odd and which one is the even place? So that's pretty much simple. See, this particular entire number is actually starting. We are actually starting from this side, right? That is the I mean right to left. So this particular digit is having the value that is 1, right? This is the first value, and this is the third value, right? This is the first value, third value, fifth value, seventh value. So these are all the odd numbers, right? So you need to pick up that particular number in that place, right? 71439. And now what are the even values? Those are in the even places. That is, see, if this is the first place, then what is this? This would be the second place. This would be the fourth place. This would be the sixth place. So those are the even places. So according to this, what are the even places here? So what are the even places here? Even places are nothing but this particular this oh sorry, not this. So even places are this. These are all the even places. Okay, so you need to calculate you need to find out all the even places, that is 1, 5, and 4, and 2. So you need to add all these numbers, that is, you need to sum it up, all these numbers. Okay, for example, 7 plus 1 is 8, 8 plus 4 is 12, 12 plus 3 is 15, right? 15 plus 9, how much? And plus 4, 13, 14, 24. So the odd places is having some kind of value, that is 24. Oh, sorry. Yeah, I have already counted this particular one also, so we should not count this one here. Okay, so why? Because these are the odd places here. That is the 7 and the 4 and the 3 and the 9. These are only the odd places. So you need to count. You need to add all these numbers. That is 7 plus 4 is 11. 11 plus 3 is nothing but the 14. 14 plus 9 is nothing but the 23 here, right? So the value the value of the odd places are 23. And if you count these numbers, that is, what are these? 1 plus 5 plus 4 plus 2, that is 6 plus 4, 10, 10 plus 2 is 12. So if you subtract, what happens? Subtract is equal to odd places minus even places. 23 minus 12. So how much? 3 minus 2 is 1, 2 minus 1 is 1, so 11. So you need to look for this particular number, whether this particular number is actually getting divisible by 11. Then you can surely say that the whole entire this entire digit is also surely divisible by 11. So see here 11. So 11 will always be divisible by 11. So you can proudly say that this entire number is also getting divisible by 11. So the condition is this. So I'll write the condition here. Don't worry. So the condition is the difference between the sum of odd places and sum of even places should be divisible by 11. Then only you can say that the entire number is actually divisible by 11. So that's the I'll tell you another example for this particular 11 number, because I know that some of you were confused actually. So I'll tell you one other example for this. Let's say I have some kind of number that is 5, 4, 6, 3, 8, 2, 2. Okay, for odd places I am choosing the color like pink. Okay, so see here, this is the odd place, right? 2, and this is also the odd place, 8. This is also the odd place, 6. Odd place. Okay, and I need to write all the odd values here, that is 2, 8, 6, 7. And now what I can do is I'll just look for the the even places, that is 2, 3, 4 and 5. Okay, so I'll write here 2, 3, 4 and 5. So I'll add up all these things. For example, if I add up 2 plus 8 is 10, 10 plus 6 is 16, 16 plus 7 is nothing but 23. Okay, so see here, if I add up all these things, 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14. Okay, so just minus. Okay, so ultimately 23 minus 14 is nothing but how much? Nothing but the 9, right? So 9. Okay, so just have a look at here, this number 9. Is it divisible by 11 or not? No, it is not actually divisible by 11. So you can definitely say that this entire number is actually not divisible by 11, right? So this is the divisibility rule for the number 11 here. Okay, now what I can do is I'll just simply consider some of the problems for just practice purpose. Okay, so that you can have some better idea. So this is the end of the divisibility rules here. Now what we can do is we can look for some practice problem. So this is the practice here, right? So this is the first problem. So the problem is 9587 minus question mark is equal to 7429 minus 4358. So how to solve this? Yes, everybody knows that how to solve this. This is nothing but you need to keep this value to the right side, and take all the values to the left side, then you can definitely calculate the things. That is, you can add or you can minus, you can do subtraction, whatever may be. But yeah, so in the same way you can calculate. See, like this, 985 minus, you can consider this unknown value as x, and is equal to, so if you subtract this, 9 minus 8 is 1, and so 12 minus 5 is 7, and 3 minus 3 is 0, 7 minus 4 is 3. So this is the value. So if you want to find out the x, so what is the value? So x will goes to the right, and this particular 3071 will comes to the left. So 9587 minus 3071. So how much? 7 minus 1 6, 8 minus 7 1, 5 minus 0 5, 9 minus 3 6. Right. So this will be the value. So this is the problem 1. Now I'll give you another problem, which is 5793405 into, okay, this is the into 9999 is equal to how much? This is the question here. So how to do that? First, this is a huge number, right? So if you want to multiply this by traditional method, it would take you some lot of time. So I won't recommend it. So what we can do is, we can just simply use some kind of technique for this kind of problem, like 5793405 into 999 is equal to, what you can do is, you can just simply consider 57. How can you write this particular statement here? 5793405 into, you can write this particular number, that is 9999 as 10,000 minus 1. 10,000 minus 1. Okay, this is the 10,000 minus 1. So see here, okay. So if you consider this, what happens? So what's our value? You need to multiply this particular number with this and with this also, right? So I'm writing this in 5793405, and you can put some 4 zeros here. Yeah, and minus, you need to multiply this number with 1. So what is the value here? 5793405. So what's the total value here? 57928256595. So this would be our total value here. So instead of approaching for the traditional multiplication method, what you can do is, you can just consider this entire number as, how can you write this? You need to think it. You need to think how can you write, in how many ways you can write this value, that is 9999. You can simply just minus 1 from 10,000, right? So that's what I have done here. So now let's move to the another example. So this is 839478 into 625 is equal to how much? So this is one kind of problem. So how to do that? instead of doing the traditional method, you can think in how many ways you can solve it. So how to write this entire statement? I can write this entire statement as 839478 into, you need to think, how can you write 625, right? How can you write 625? Just think, how can you write 625? So you know that we everybody knows that 25 into 25 is not, that is the 25 square is nothing but the 625, right? So 25 into 25 is nothing but 625. So how can you write this particular 25? You can write this 5 square, right? Into, how can you write this 25? 5 square. So whole thing is 5 square into 5 square is nothing but 5 power 4, right? So you can write this in this way, 5 power 4 here. So now you can also write this 5 power 4 as like this, 839478 into How can you write this 5? You can also write this 10 divided by 2, right? And whole to the power of 4. Okay. So now what you can do is you can just multiply these things like 8, 3, 9, 4, 7, 8 into 10 to the power of 4 divided by 2 to the power of 6, 4. So what is the value of the 2 to the power of 4? That is nothing but the 16 here. Okay. And if you multiply these things, what happens? You need to put 4 zeros besides this number. 1, 2, 3, 4 here, right? So it would be very much easy to solve this. So you will get the answer some kind of 5, 2, 4, 6, maybe 7, 3, 7, 5, 0. So this would be your answer. Okay. So now let's consider another example, that is another problem, that is the fourth one. So in the fourth problem, I have some 976 into 237 plus 976 into 763 is equal to how much? You need to find these things. So how to do that? How can you do this? So you can do like you can take this common here. You can take 9 out of all these things. 976 is common, so you can take 976 as common, and you can write like this: 237 plus, see here, out of all these things, 976 here and 976 here are common. So I'm taking the common 976 value. So you are left with this particular value and this particular value. So that's nothing but plus 763 here, right? So if you look at here, 976 into, you need to add it up. So 7 plus 3 is 10, 3 plus 6 is 9 plus 1, 10, 2 plus 7 is some 1000 here. So we will get the value of 1000. So multiplying with, 1000 is very much simple. 976,000 is our answer. So this is the another problem here. So now let's look at another problem, that is the fifth problem. 986 into 307 minus 986 into 207. Okay, so this is also the same. Why? Because see here, 986 are common here. So 986 of 307 minus 207 here. So what's the value here? 986 of 307 minus 207 is nothing but 100. So you will get the value of 986,000. This is our value here, right? So let's move on to the another example, that which is the sixth one. We have some kind of problem like 1607 into 1607. How to do that? You need to check the value of this. You need to calculate this. So how to do that? We know that this is a multiplication of the same number is nothing but the square, right? You can write 1607 whole square. You can write in this way. So how to deal with this number 1607? You can also write 1600 plus 7 whole square, right? So this together has formed a plus b whole square formula. So what's the formula for it? A square plus b square plus 2ab. This is the formula. So what is the a square here? 1600 whole square. Okay. Now what's the b square here? 7 square. What is the 2ab? 2 into 1600 into 7 here. So you can just square 16 into 16 here. What is the value of 16 into 16? That is 256. And keep the 4 zeros here. 1, 2, 3, 4. Now 7 square is 49 here. Okay. We know that 2 into 16 is 32. 32 into 7 is what's the value of the 32 into 7? That is 14. 7 there is a 21. 22, 4 here. So put the double zeros here. So if you add it up, 2582449 will be the value of this entire problem. Okay. So now the similar kind of problem, that is 1396 into 1396. So how to deal with this number? That's the very much simple. here like this square. So how to deal this? You can also say like 1400, okay, minus 4. You can also write like this. So this together forms a minus b whole square formula. So what's the formula for it? So a square minus a square plus b square minus 2ab. This is the formula here. So how to write in this particular format? 1400 whole square plus 4 square minus 2 into 1400 into 4 here. Okay. So what's the 14 into 14 is nothing but 196, right? 14 square is 196. Put 4 zeros here. And 16 minus 2 into 14, 28. 28 into 4, how much? 4 3s, 28 into 4. It 4s are 32 here. So next 4 to 8, 8 plus 3, 11. Put 2 zeros here. So what's the value here? Finally, 1948816 is the value of this particular problem. Okay. So now, okay. So let's see this particular problem. That is 8th problem, which is 475 into 475 plus 125 into 125 is equal to how much? You need to ask this. You need to find out this. So what's the, see here, what's the common thing here? These are the same values. These are also the same values. So you can say that a square plus b square. So this is the formula here, a square plus b square. So what's the formula for the a square plus b square? It's nothing but a plus b whole square plus a minus b whole square entire divided by 2. So you need to you need to solve this problem in this particular formula format. So a is nothing but 475 here, okay, plus b is 125 here whole square plus a is 475 minus 125 whole square and divided by 2 here. So what's the value here? 400 plus 100, 500, 500 plus 90, 90 plus 600 here, plus 400, 5 minus 5, 0, 7 minus 2, 5, 4 minus 1, 3 whole square. Okay, so divided by 2 here. So now what we can do is you just need to square this. 6 is 36. Put 4 zeros here. Plus 35 into 35. You need to find out what is that? 1225. Put 2 zeros here. Divided by 2. Just add it up, all these things. So you will get 241250. This would be your answer. Okay. Now the 9th problem is 796 into 796 minus 204 into 204 is equal to how much? This is the thing. See here, this is also the same a minus a square minus b square formula. So what's the formula here? A square minus b square. What's the formula here? A plus b into a minus b. So every single problem is actually based on these kind of problems here, these kind of formulas here. So you need to focus here. So a plus b is nothing but 796 plus 204 into 796 minus 204. So how to deal with this? 6 plus 4 is 10, 9 plus 1 10, 7 plus 1 8, 9 10, 1000 into 6 minus 4 is 2, 9 minus 0 is 9, 7 minus 2 is 5. So 592000 is the answer for this. Okay. So just move on to the next question. is the 10th question here. 387 into 387 plus 13 into 13 plus 2 into 387 into 113. See, if you just focus here, this is in the form of a square, b square plus 2ab. So what's the formula for this? A plus b whole square. So how to do that? 387 plus 113 whole square. That's simple, right? So just sum it up. 7 plus 3, 10. 8 plus 1, 9 plus 1, 10. 3 plus 1, 4 plus 1, 5 whole square. So what's the value? 5 5 is 25. Put 4 zeros here. This would be our answer. Right. So yeah. Okay. Yeah. So I think that's all for this video. Now we have looked what we have done so far. We have already learned what are all the divisibility rules. Divisibility rules of numbers 2, 3, 4, 8, 5, and 9, and 11, and 10. Right. So we have looked for all these numbers, which are nothing but the divisibility rules. So and then we have tried some kind of practice problems based on earlier video, not this particular topic, or not on the divisibility topic, but the part 1 video of this aptitude series, right? Practice problems on part 1 video, that is aptitude number system, right? So we have done this now. Okay, we will try to cover some other practice problems in the next coming video. So just please stay tuned to my channel, and if you like the content, just please subscribe. So this is an honest attempt to, this is an honest attempt which I have made. So if you like it, please like the content and share with your friends, so that they also can learn something from these videos, right? So that's all for this. I'll see you in the next video. Bye bye. Take care. Happy weekend and happy Diwali. Jai Hind.